You're welcome to Phenomen's page. In today's lesson, I'll discuss with you equality of vectors. This is what you're supposed to know. Now, when vectors are equal, then they have the same magnitude. They also have the same direction. That is what you're supposed to know. Now, in terms of components, that is this. Assuming we have the vector A, which has components, 2, 4. Another vector B also has the same component, 2, 4. So you can clearly see that the vectors are the same because they are having the same components. And because of that, we say their corresponding components are the same. So that is the vector A is equal to the vector B. A has component 2, 4, so it is equal to the vector B, which also has component 2, 4. So you can see that, in fact, their corresponding components, the S component for the A is the same as the S component for the B, and the Y component for the A is the same as the Y component for the vector B. So we can now say that when vectors are equal, then their corresponding components are the same. We're going to use this idea to answer some questions. You have to know that when vectors are equal, then they have the same, corresponding components. Now let's take some questions. Our first question. If the vector A has component, so the vector A has component, so let me get it here. So these are the components, 4x plus 3 as the S component. And we come to the Y component, we have 5 plus 2y. And the vector B also has component. So that's the vector B. We have 11, -5. This is the question. We have to find the values of x and y if A is equal to B. This part is very, very important. That's the condition that we're going to use. So the condition is that A is equal to B. So that means the vectors A and B are equal. So if the vector A is equal to B, then this will imply that now these are the components of the vectors. 4x plus 3, 5 plus 2y, that's the vector A, is equal to the vector B, which also has components, 11, -5. So you have to deduce this one. So this vector is equal to this vector. Now, we said that when vectors are equal, then their corresponding components are also equal. So this implies that, this one and that, they are equal because they correspond. So we can say that 4x plus 3 is equal to 11. We can call this one equation 1. And when you come to the bottom, we have 5 plus 2y, which is also equal to -5. We can also call this one equation 2. So now back to the question. We have to find the values of x and y. Now we can see that from the equation 1, we have x, and from the equation 2, we have y. So we can find the value of x from the equation 1. So let's find the value of x here. And what's the equation? The equation is 4x plus 3 equals to 11. So you can say that this is, a simple equation. To find the value of x, you have to subtract, 3 from both sides. So you're going to get 11 minus 3 here. So we have 4x equal to 11 minus 3 is 8. You can just divide here by 4, here 2 by 4. And now x is equal to, 2. 8 divided by 4 is 2. Now we can also go ahead and find the value of y. The equation is 5 plus 2y equals to -5. So what do we do? You have to subtract 5 from both sides because we want to find, y. So we're going to get 2y equal to -5 minus 5. So you have 2y equal to -10. So you have to divide both sides by 2. So when you simplify, we have 2y equal to -10. So 2 can cancel itself 1. It can also go into itself 1 here. Now let's simplify this one. 2 here, 1. 2 goes into 10 5 times. Don't forget we have the negative sign here. So that means y is equal to -5. Now, we are done. The values of x and y are 2 and -5 respectively. You want to, verify for yourself. Remember we said that the vectors are the same. The vectors A and B are the same. So let's do the verification here, even though this is not part of the question. So now the vector A has component, 4x plus 3. And then the y component, we have 5 plus 2y. Now that we know the values of x and y, remember, x is equal to 2 and y is equal to, negative 5. So we're going to verify here to see whether the vectors a and b are the same. So let's do the substitutions here. So we're going to get 4 times x, and x is 2. So 4 times 2 plus 3. We come to the y component. We're going to get 5 plus 2 times y. And y is negative 5. So that will give me, 4 times 2 is 8 plus 3. And now we have 5. 2 times negative 5 is going to be negative, 10. So 8 plus 3 will give me 11. And 5 minus 10 will give me negative 5. So that means the vector A has this component. Remember, the vector B also has the same components. Yeah. So that means the vector A is equal to the vector B. That is it. Let's get our next question. Given the vector P with component 2, 3, and out of Q with component 2, 5, and R is equal to half, multiplying the sum of the vectors, P and Q, we have to find the vector R. So this is a typical vector equation. So this is a vector equation that we're going to use here. Now this is the equation R equal to half multiplying the vectors Q plus P. Now to do this, we have to do substitutions so that we can find the value of R. Now the information is given already. So we have half. Now let me use this bracket for this one so that the vector Q can be written here and it has components, 2, 5 plus the vector P, which also has components 2, 3. That is it. So we have to simplify to get the value of R. Now, we have to simplify the ones in the bracket before we even multiply the scalar, which is half, by it. So I have to maintain half outside the bracket. And now inside the bracket, we have this one. The vectors Q plus the vector P. You should remember that in adding vectors, we add corresponding components. So 2 and 2, they are corresponding. So we're going to get, the vector 2, the component 2 plus 2. When we come to the S component, the Y component, we have 5 plus 3. So that is how we can set up everything. Now we can simplify to get this. 2 plus 2 will give me 4, and 5 plus 3 will give me 8. Okay. We can still multiply, the scalar, which is half, by everything in a bracket. So we have to multiply. And we're going to get, 4 times half and 8 times half. And that will give me, half of 4 will give me 2, and half of 8 will give me 4. So that's the value of R. So the vector R has component 2, 4. Question, given that the vector M has component x minus 4, 3, and N also has this component 5, 3 minus y, we have to find x and y if M is equal to N. This is very, very important. That's the condition. So the vector M is equal to the vector N. That's the condition. So if that's the case, then we can set up this equation. The vector M has component, x minus 4, 3. It is equal to the vector N, which also has component 5, 3 minus y. So that is our equation. Now, when vectors are equal, then their corresponding components are also equal. So this component and that of this, they are equal. So take notice of that. So we can say that x minus 4 is equal to 5. So straightforward, let me even find the value of x. So we can say that x is equal to, this is a simple equation, 5 plus 4. So x is equal to 9. That is it. Let's get the value of y. Okay, so now that we have the value of x, let's get the value of y, from the y component. So you can see that this one is also equal to, this component because they are equal. So now we can say that 3 is equal to, 3 minus y. How do we find the value of y? We have to subtract this 3 from both sides. So I'm going to get 3 minus 3 equal to 3 minus 3 minus y. So that will give me 0 equal to, 3 minus 3 is 0. So we have negative y. Now we want y, not negative y. So I have to divide through by negative 1, here 2 by negative 1, so that I can, do away with the negative sign. So that means that 0 divided by negative 1 is going to be 0. So that means y is equal to 0, right? Now, we are done with the question. But I want us to check something. We are going to verify to see whether the vectors m and that of the vector n are equal. Let's see. Now, m is equal to, x minus 4 as given initially. Now that we know the value of, x, we can find the exact value of what? M. So x is equal to 9. So that's going to be 9 minus 4. So I'm just doing substitutions. So in place of x, I'm just writing, the value of x, that is 9. So you see, 9 minus 4 is 5. And then we have 3 here. So that means the value of m is 5, 3. Let's take the vector n. N also has components 5, 3 minus y. Now we just saw that the value of y is 0. So that's going to be 3. In place of y, I'm going to write, 0. So it's going to be 3 minus 0, and that will give me 5, 3. So you see we are getting the same, answers. That means that the vectors m and n they are equal. Okay, so let's get our next question solved. We have to find the values of x and y in a vector equation, and that's a vector equation. So let me get it here. We have x plus 3, 2, minus the next vector is 2, y plus 2 equal to the next vector, that is 2, negative 1. So that's our vector equation. Okay, so now we can, subtract the corresponding components. Remember, we can subtract corresponding components. So that's going to be x plus 3, minus 2. That will be for the x component. Now let's come to the y component. And that's going to give us, 2 minus y plus 2 equal to the right-hand side, that is 2, negative 1. So that is it. We can simplify the left-hand side. Now we can collect some like terms here. They have been grouped already. So now we have x, 3 minus 2 is going to be 1. So x plus 1, we come to the bottom. We have to collect like terms here. So you're going to get 2 plus 2 minus y equal to, 2, negative 1. Okay, so let me continue from this end. So now x plus 1 cannot be simplified again. So we have x plus 1. Now 2 plus 2 is 4. So we have 4 minus y equal to the right-hand side, which is 2, negative 1. Now at this point, we can simplify the left-hand side again. We can't do anything to, x plus 1 and 4 minus y. We can't do anything. So we should remember that these vectors, this vector and that of that, they are equal vectors. And because of that, their corresponding components are also equal. Okay, so now we can set up the equation like this. So let me equate, the x component. So x plus 1 is equal to 2. Yeah? And we can find the value of x right now here. So I have to subtract, 1 from both sides. So that will give me, x equal to 2 minus 1 and x is equal to 1. So that's the value of, x. Let's get the value of y. Okay, so from the y component 2, that is this one, 4 minus y is equal to negative 1. So they are equal. 4 minus y is equal to negative 1. So to find the value of y, I can subtract 4 from both sides. So that's going to give me negative y equal to negative 1 minus negative 4. Minus 4. So negative y is equal to negative 5. So we divide both sides by negative 1 so that we can get y. Here to by negative 1. So the negative, they will just, do away. So we have y equal to 5 on 1, which is 5. So y is equal to 5. So we are done. These are the values of x and y. If you want to verify, you can verify. Another interesting question. You have the vectors a, b, and we have this vector equation. Now this is the vector equation. K multiplying a minus b equal to half multiplying the vector, negative 6, 64, 64. So that is it. That's the vector equation. Now we have to do substitutions here. We have to find the value of k. That is k. So let's do the substitutions here. We have k multiplying the whole of this one. Now a is a vector which has component negative 7, 6 minus b is also a vector with component 10, negative 11. Now it's equal to half multiplying, negative 64, 64. Okay, so now at this point we can simplify the ones in the bracket here. So we have k multiplying. Now in the bracket we have negative 7. We can subtract the corresponding component. So negative 7 minus 10. That will be for the the s component. And with the y component we have 6 minus negative 11. And it is equal to, now we can simplify this part. Half is a scalar multiplying this vector. So you're going to get negative 64 times half. When you come to the y component too, we're going to get 64 times half. Okay, so we can simplify this side, and I want to simplify this one. So half of, negative 64 will give me negative 32. And half of 64 is going to give me 32. So we can get this one here. Now, let's simplify this one too. Negative 7 minus 10 is going to be negative 17. And out of 6 minus negative 11 is going to be 6 plus 11. That is 17. And it is equal to, the simplified form. That is going to be negative 32, 32. So this is what we have. Now, k is a scalar. So we can multiply this scalar by this vector. So now we multiply, we're going to get k times negative 17. We have negative 17k. And k times 17, we're going to get 17k. And that is equal to, negative 32, 32. So that's what we have. Now, these vectors are equal. And because of that, their corresponding components are equal. Now we have k on the x component. We also have k in the y component. So if you want to find the value of k, you can use any of the components. So I want to use, the y, because I want to do away with the negative. So let me take, 17k equal to 32. Now, to find the value of k, I have to divide both sides by 17. So here 2 by 17. So this 17 will cancel this 17. So we have, now 17 cannot go into 32. So you can simplify this one to, one whole number, 15 out of 17. So that's the value of k. So that is how we can find the value of k. So k is an improper fraction.